All right, welcome to the Explainer. Today, we're cracking open a cold case that's, well, it's about 350 million years old. So, picture this 350 million years ago. We're talking way before the dinosaurs. The Earth was basically this giant, steamy, swampy jungle, and it was ruled by giants. But not the kind you're thinking of. No giant lizards or mammals. We're talking about giant insects. And when I say giant, I mean giant. Can you even imagine a dragonfly with a wingspan of 2.5 feet? I mean, that's like the size of a hawk. This thing, Meganeura, it was one of the top predators in the sky back then. And if you think that's nightmare fuel, wait till you hear what was crawling around on the ground. Arthropleura. It was a millipede that grew up to 8.5 feet long. Let that sink in. A millipede the length of a small car, weighing over 100 pounds. This wasn't just some bug, folks. This was the biggest land invertebrate ever. So the big question is, how on earth was this even possible? Well, to figure out what killed these giants, we've got to go back to the beginning. We need to investigate the scene of the crime, so to speak, the world that made them. So here's the secret sauce. It was literally in the air. Back in the Carboniferous period, the Earth's atmosphere was just souped up. It was packed with oxygen, around 35%. Compare that to the 21% we're breathing right now. So where did all this extra oxygen come from? Well, you had these massive swamp forests just pumping it out. And get this, the fungi and bacteria that decompose dead wood hadn't really evolved yet. Now, you gotta remember, insects don't have lungs like you and me. They breathe through this wild network of little tubes. It's called a tracheal system that pipes oxygen straight to their cells. It's a pretty slick design, right? But it's not super efficient over long distances. And that's the reason in our world today that there's a hard limit on how big an insect can get. But back in that super oxygenated world, breathing was a breeze. That size limit, it just, poof, vanished. It was like evolution got a giant green light to just go wild with making insects bigger and bigger. So yeah, the really crucial question is, what or who turned that green light red? You know, for more than 100 years, scientists thought they had this case cracked. It seemed open and shut. They had a prime suspect, the air itself. The very thing that gave the insects their size was also what killed them. Or so they thought. So about 300 million years ago, the world started to change, big time. We call it the Carboniferous rainforest collapse. Basically, the planet started drying up. Those huge, sprawling swamps began to shrink. And this is the really key part. Bacteria and fungi finally figured out how to eat dead wood. So for the first time ever, dead trees started to rot. All that carbon that had been locked away for millions of years, it all got released back into the atmosphere as CO2. The planet's giant oxygen-making machine just started to sputter and fail. And over a few million years, the oxygen levels just plummeted, from that crazy high of 35% all the way down to the levels we see today. Now, imagine you're one of these giant insects. Your whole body, your entire biology is built for a world swimming in oxygen. This change, it was an absolute catastrophe. Their bodies were just too big. Their breathing systems couldn't keep up. They were pretty much suffocating on a planetary scale. And, you know, for the longest time, that was it. That was the story. The air changed, the giants died. Case closed, right? Well, not quite. Because then, some new evidence turned up. Fossils that blew the whole investigation wide open. So paleontologists are digging around in rocks from the Permian period. Now, this is millions of years after the big oxygen crash. And what do they find? Giant dragonflies, things like Meganeuropsis. And we're not talking about some shrunken down survivors here. No, these things still had wingspans of up to 28 inches. That's huge. So hold on. If these giants could survive in a low oxygen world, that means our number one suspect, the air, had an alibi. It couldn't have been the only killer. So the investigation had to be reopened. The question now was, who were the accomplices? Well, it turns out the giant insects were about to face a totally new kind of danger, a threat that came from the skies. And this new threat, it turned their greatest strength, their massive size, into a fatal weakness. Okay, so for a mind-boggling 150 million years, insects owned the sky. They were the undisputed kings. But that was all about to change. First, you get these gliding reptiles. They were probably more of an annoyance than anything. Then came the pterosaurs, actual flyers, and that definitely ramped up the pressure. But the real revolution, the thing that completely rewrote the rules of air-to-air combat, that showed up around 150 million years ago. I'm talking about the evolution of the first true birds, creatures like Archaeopteryx. Suddenly, there's this new, terrifyingly good aerial predator on the scene. For the very first time, these giant insects were being hunted down by fast, agile, feathered killers. Okay, so check this out. This is the work of a researcher named Matthew Clapham, who looked at over 10,000 fossils. And this is where it gets really interesting. Look at the Jurassic and Cretaceous periods. See how the oxygen levels are actually going back up? You'd think insect sizes would go up too, right? But look what happens. The maximum size keeps getting smaller. That right there is the smoking gun. It wasn't about oxygen anymore. The main thing driving insect size was now predators, specifically birds. All of a sudden, the entire game had changed. Being a giant, slow-moving target in the sky, that was basically a death sentence. The whole direction of evolution just flipped. It wasn't a race to be the biggest anymore. Now it was a race to be the fastest, the most agile, the hardest to catch. So, you see, there was no single killer. It's like one scientist said, this whole mystery is like an Agatha Christie novel. There wasn't just one murderer on the train, there were a whole bunch of them. The final verdict? The giant insects died because of a perfect storm, a conspiracy of environmental chaos, and a brand new evolutionary arms race. Yeah, it was really death by 1,000 cuts playing out over millions of years. First, their homes, those giant swamp forests, disappeared. Then, the plants that the big herbivores like Arthropleura ate just died out. And now they were competing for the same food as the very birds that were hunting them. And here's the final weird twist. The rise of flowering plants, as beautiful as they are, might have been the last nail in the coffin. They changed the chemistry of the water in lakes and ponds, which killed off the babies, the larvae of the last of the giant dragonflies. And this just perfectly sums up the whole story, doesn't it? Back in the ancient world, the big question for an insect was, is there enough oxygen for me to get bigger? That was the limiting factor. Today, the limiting factor is, can I get away from that bird or that bat that's trying to eat me? It's the constant threat of being eaten that keeps insects small now. So in the end, it took a planet-wide suffocation event, the complete collapse of their world, and the rise of a whole new dynasty of flying predators to finally bring the 150 million year reign of the giant insects to an end. It's just such an incredible story, right? It shows how even the most dominant life forms on the planet can be brought down when everything changes at once. The air, the predators, the whole ecosystem. It took that perfect storm to end their reign. And that kind of leaves us with a pretty chilling question for our own time, doesn't it? As we humans create our own version of a perfect storm of global change, can today's insects survive us?